Okay, take a seat, make yourself comfortable, because you are about to embark on a journey as far away as possible in time, towards eternity. Because as strange as it may seem, the trajectory of your life is infinitely more complex than that of orbiting bodies, than celestial mechanics. If no one can predict your future, it may be different for that of the universe and everything that constitutes it. If we look at the laws of nature that govern them, we can see the future of distant futures reflected in them. And since we can partly predict them, here is their story. When the light for us goes out, the matter that once constituted us will continue to exist and the stars to shine. After 2,366 years, Halley's Comet is returning to the inner solar system. 10 millennia later, the red supergiant star Antares goes supernova. The immensely luminous star becomes visible in the sky to our descendants, even during the day. And the Earth continues to spin, on itself, slower and slower, slowed down by the tidal effects generated by the presence of the Moon at a rate of 0.02 seconds per century. So much so that in 50,000 years, we will have to add a second to the length of the day. 1 second more per Earth rotation later, for the so-called astrologers, things start to get complicated because the movement of the stars moving in our galaxy has ended up transforming the celestial vault, where hundreds of new constellations are now drawn, in a sky that no longer resembles, in any way, the one we know today. 200,000 years have passed again, and the Voyager 2 probe passes close to Sirius, currently the brightest star in our sky. We have now passed the point where, given the frequency of impacts, the Earth has presumably taken an asteroid more than a kilometer. And after 1 million years of enduring the ravages of time, of being sandblasted by rain, by winds, the Great Pyramid of Giza, like all stone buildings today, is beginning to become unrecognizable. On the Moon, all the footprints left by the astronauts of the Apollo missions have now completely disappeared, erased by the action of cosmic rays and other space erosion phenomena. And it's somewhere around there in these completely transformed skies that a second small sun appears for a few weeks. The red supergiant Betelgeuse has exploded into a supernova. Easily visible during the day, the dying star rivals the full moon in terms of brightness at night for several weeks. And in a stride 450,000 years later, star number 710 passes close enough to ours to disrupt the Oort cloud, sending dozens of comets towards the inner solar system. The millions of years pass, and the Earth's crust continues to move along its lines of fracture and weakness. The opening of the East African Rift now forms a new ocean basin between the Horn of Africa and the rest of the continent. Australia is shifting northward, California is separating from the US, and at a temporal distance thrice as great. We find Mars adorned with rings. They formed following the disintegration of the small moon Phobos, battered by tidal interactions caused by the red planet. It is thought that these structures should remain in place for 1 to 100 million years. On our planet, the ground, however, continues to move. Africa, having collided with Eurasia, closed off the Mediterranean Sea. Volcanoes are born and die, mountains rise, others disappear under the onslaught of time and erosion until, in a giant puzzle game, all the continents eventually come together to form only one. 240 million years have passed, and our solar system has now completed, from its current position, a full orbit around the center of the Milky Way. 60 million years later, with rings, Saturn is no longer the Lord. The dust and ice that made them up have all been degraded by the ultraviolet radiation emitted by the Sun and by the plasma generated by repeated collisions with micrometeorites. Captured by the magnetic field and gravity of the gas giant, they eventually plunged into it. And at a distance twice as far in time, on Earth, the apparent size of the Moon is now too small to completely mask the Sun. It has now become impossible to witness a total eclipse of our star, which slowly gains in brightness. And already, for life as a whole, things are starting to get seriously complicated. The increasing intensity of the Sun, which has increased the erosion of surface rocks, has ended up trapping the carbon dioxide from the air in the ground. Meanwhile, Earth's tectonic plate activity is slowing as the planet ages. Volcanic activity is gradually ceasing. Without volcanoes to recycle carbon into the atmosphere, the CO2 level drops drastically until photosynthesis becomes impossible for almost all plants. For those who might be there, it's high time to think about getting out, which is still a bit annoying. 200 million years later, the atmosphere is devoid of free oxygen and ozone. On the surface, all forms of multicellular life have gone extinct. And now the brightness of the sun reaches a level 10% higher than it is today. The average surface temperature is now 50 degrees, and the oceans are beginning to evaporate, gradually turning our world into a real sauna. On the surface, only a few elementary forms of life still resist, perhaps at the level of the poles, to this hell. It's now been 1 billion years since the Voyager 1 and 2 probes were launched. They are probably still drifting in space, 25,000 light-years from their starting point. And the information engraved on the 2 golden discs they carried due to the bombardment of cosmic radiation has become unreadable. 1,300 million years later, the Earth's outer core has cooled enough to solidify. Gradually, its movement stops, and with it, the Earth's magnetic field. Deprived of these protective shields, the hypothetical remaining forms of life are subjected to the deadly bombardment of high-energy particles coming from our Sun. In the skies of this time, the Andromeda Galaxy, which is rushing towards us at a speed of 140 kilometers per second, has become distinctly visible to the naked eye, now more imposing in size than the full moon. 500 million years have passed again. The surface temperature of the globe is around 150 degrees. And our blue planet is only that in name now. Except perhaps for some unicellular colonies relegated to very high altitude lakes or underground caves, nothing here can survive. On Earth, life is extinguishing. And now the distance from the Earth to the Moon has become too great for the latter to maintain its stabilizing effect. The tilt of the Earth's axis becomes chaotic. 600 million years later, Triton, one of Neptune's moons, disintegrates in turn under the effect of the tidal forces of its gas giant. And after spending more than 3 billion years without a ring, our solar system sees the blue giant take over from Saturn. In the skies then begins a diffuse and gentle collision with Andromeda. Launched into a strange dance, the 2 galaxies see the clouds of gas and dust that make them up partly merged. From these games of disturbances and influences, hundreds of millions of new stars will be born. And this chaotic ballet is not about to stop, as it will spread over nearly 3 billion years until, in the end, only one giant galaxy remains. It has already been given a name, Milkomeda. And it is in this environment bathed in the light of new stars that in 5.4 billion years, the death of ours begins. After exhausting its hydrogen reserves in its core, our Sun leaves its main sequence and begins to transform into a red giant. At the end of this phase, our star has become 2,700 times brighter than it is today. And in its expansion, by multiplying its radius by 250, it has vaporized Mercury and Venus and comes to lick or even engulf our planet, carbonized by the one that allowed it to be born. And barely 100 million years later, there is already nothing left at the center of the system but a tiny, pale white point, barely visible. A dying star, a white dwarf, where 50% of the Sun's mass is compressed into a volume barely larger than Earth, and around which the surviving planets continue to orbit. Now surrounded by a planetary nebula, vast sheets of gas expelled from the outer layers of the Sun. At the center, the residue of dead stars, it inexorably cools, becoming paler and paler, and to definitively no longer be able to see it, we will have to go twice as far in our history. And here is our Sun, now out of the visible realm, turned into a black dwarf. Its surface temperature has dropped below 2,000 degrees, and visually, the remains of the star have gone out. The king is dead. Long live other kings, for even then, in 1,000 comedies, as in the entire universe, the sky is still populated with billions of stars. Some, newly formed, from gas clouds collapsing on themselves, have just lit up. Others, massive, die in colossal explosions. Some, even smaller, older, simply continue to shine as they always have. The following tens of billions of years remain illuminated by their light. Yet, inexorably, the deep sky empties. Because the universe is also aging. And in doing so, it grows, expands, to the point where the stars located beyond our local cluster come to gradually shift towards red, moving too fast, too far. They are forgotten by us for eternity. For hypothetical inhabitants of these future worlds, the cosmos has visually become an island universe. All galaxies located beyond our local cluster, passing behind the cosmological horizon, have become inaccessible to their eyes. But in the galactic neighborhood, mergers continue, bringing each time their share of new stars in the sky. And after 450 billion years of colliding, merging, the 50 or so galaxies that surround us today end up forming only one hypergiant, within which, slowly, surely, the gas clouds are drying up. Because even if, at the death of the stars, some of the matter can be ejected into space, where it can continue to contribute to the formation of other celestial bodies, the vast majority remains trapped in their dying heart. Thus, in the long run, each sun is in itself a small fuel prison. Inexorably, throughout the universe, galaxies are running out of their fuel and seeing their brightness decline. The formations of new stars are now extremely rare. Until the moment comes when, with the universe 1,000 times older than it is today, the very last one of them lights up. We have just entered the Degenerate era. No more gas clouds will ever light up. Sun after sun, the universe is emptying of all its light. The giant galaxies contain nothing more than tiny, low-mass stars, red dwarfs, some of which are still capable of shining for over 1,000 billion years, as long as the universe's age at that moment. But while we have long thought of stars as immortal, we have discovered that none are. And when the universe becomes 10 times older, the day comes when the very last star goes out. Visually transformed into a dark body, all the kings are dead. And time continues to pass. The universe continues to exist. The cosmic clock keeps turning. Older by a second every second, it is still young compared to the time to come. And the ink-black skies are not yet totally so. In each giant galaxy, for thousands of billions of dark bodies, there are actually on average a small 100 active stars. Because when eternity is before you, the improbable can only end up happening. These formed as a result of extremely rare collisions between two extinguished celestial bodies which, occasionally, when they collide, merge and reignite. In extremely rare cases, binary systems of dead stars orbiting each other avoid collapse. From their fusion, novas can be born, which, with their fleeting flash, come to dissipate the darkness of the degenerate air for a few weeks, before all returns to darkness. Until such an event happens again, before no more ever occur. In this now total darkness, however, there are still bodies, remnants of brown, white, or neutron stars, and black holes. All these stellar remnants continue to orbit around the galactic center. Their paths cross, sometimes brushing against and destabilizing each other. The lighter celestial bodies, the frozen planets, having escaped the death of their star, and which still orbit around them, will be the first to bear the brunt of these gravitational disturbances. Everywhere in the universe, the passage of compact celestial bodies in their vicinity will, over time, undermine the stability of their orbit, to the point of tearing them away from their system. As for the few surviving planets from this cosmic billiards game, they will eventually see their orbit as tired, to the point of ending up crashing into the star at the center of their system. Stars whose temperature continues to drop. Most have long since passed the stage where one could touch them without getting burned. Their surface temperature has dropped below that of your refrigerator. And when 1,000,000 trillion years have passed from our present, the fiery surface of our Sun is less than 168 degrees Celsius. And in the universe, nothing happens for a small eternity. To see something interesting happen again, we will have to move forward until the universe is 10,000 times older than it is at this moment. And after thousands of billions of years of exchanging orbital energy, accelerating, it is now the turn of the most massive drifting stars to be ejected from their galaxy. The majority of them thus set off to wander in the cosmos. While a small part, survivors of this cosmic billiards game, see their orbit as tired and over time end up plunging towards the supermassive black hole that reigns at the center of each galaxy. Fueled by these stellar remnants, it becomes for a time the theater of gigantic explosions of matter and radiation. In the end, such will be the destiny of all stellar remnants. And when the universe is then 1,000,000 times older than the age it was when the last stars went out, the galactic structures have been totally stripped, and the clock, it keeps ticking. We have entered the era of the Big Chill, and the universe, which is still but a baby in the face of the times to come, is merely a vast expanse of dust, rocks, and drifting celestial objects. The distant futures are always just beginning somewhat. But don't leave, because what starts to look like a never-ending story may hide millions of happy endings at the end of the race. What follows will depend on the stability of something within us, the matter itself. Because even if heat, light, and stars have taken the exit, the atoms, they are still there, part of the game. As cold and solid as they may be, all elements are still very much present. And to know what awaits them, we need to focus on a question. Are the bricks that make up matter in the very long term eternal or unstable? And even if no one has ever seen an atom die, perhaps the universe will see it. If the protons found in the heart of all atomic nuclei turn out to be able to die, to be unstable, then, to make it short, after durations ranging from estimates of 10 to the power of 34 years to 10 to the power of 43 years, one after the other, the protons will disintegrate. And with them, matter, which has become incapable of structuring itself, disintegrates. All that remains, drifting stars and wandering planets, rocks and dust, all, absolutely all matter as we know it, will disappear. Emitting in the process a derisory amount of energy, the only one available in the universe, to the point where a frozen star of the mass of our Sun only releases an amount of energy of the order of that of your microwave turned on, which frankly is still quite a bit. And time continues to tick away. Until after something like 10 to the power of 40 years, the universe becomes so cold that it drops below the temperature of the black holes themselves. From then on, they will start to evaporate, and the light will make its return. It takes the form of violent episodic flashes that originate from the darkest objects that exist, because this strange process of evaporation ends for each black hole in the form of colossal explosions, which briefly disturb the darkness of this theatre that has been without spectators for a long time. These episodic flashes continue until the last of the black holes disappears. Now only elementary particles incapable of binding and extremely diluted and tired photons remain. In a space where nothing forms, nothing happens, we have entered the dark era. From now on, silence is the only object of the sound void. The temperature is flirting with absolute zero. The universe is thermally dead. It has nothing ahead but eternity, which, let's be honest, is still as impressive. But don't leave. Hope is always the last thing to die, because there could be a different fate. If the proton turns out to be stable, then bingo. Matter has not yet had its last word. It is still present during the era of black holes. And when the universe shows on the counter 10 to the power of 65 years, all the things it still constitutes start to arrange themselves in an exotic way by tunnel effect, giving matter a liquid appearance. Then, long after the last black holes have evaporated, in the face of infinite durations, although highly unlikely, even the slightest probability ends up happening. And occasionally, matter sees the nuclei of these atoms spontaneously fragment or merge, altering their atomic structure to tend towards a state of maximum stability. And at the end of a process spanning from 10 to the power of 500 years to 10 to the power of 1500 years, all matter has transformed into iron, the most stable atomic element in the universe, which is not the most stable state of matter. Is a neutron mush even more stable? That's why, on inconceivable timescales, through tunnel effect, stars, planets, and iron dust transform into neutron mush. Mush that collapses into blacks, which in turn evaporate. And in this scenario, as in the first, after clinging on for durations that have long since surpassed a tired imagination, and while the universe displays on the counter 10 to the power of 10 to the power of 66 years, matter disappears. Decidedly, it always ends up doing. The expansion, however, continues, and provided that talking about time still makes any sense. Forever. Cut. Except that this end clap may not be a full stop. In suspension, it could be the starting point of news stories. Camera, action. It will take as long as it needs to, but it will take it. Time is not what it lacks. It's even all that remains to the universe. And there will come a day when it will be 2, 4, 100, 1,000 times older than it is at this moment. Even then, time will keep flowing. And what can happen will inevitably end up happening. There is a theory that when the clock displays the surreal number on the counter of 10 to the power of 10 to the power of 56 years, then parts of the universe that have become empty and cold enough could reach a state of energy even lower than the vacuum we know. Descending to this level of exotic energy would have the consequence of rewriting the laws of nature in these regions of space. Different laws that through inflation would give birth to something new universes. By the thousands, by the millions, an infinity of other universes. Perhaps this has already happened, that ours comes from it. Perhaps it will happen again, over and over, this time definitively, for eternity. For eternity. It was a challenge for us to get involved in this. Between shooting on the Normandy beaches in the middle of winter and some good heavy brain juice and writing sessions until the early morning. Behind all this, there are people, especially you, without whom we would be talking into the void. And who are still here, even at this point in the video. Anyway, a huge thank you. And even more particularly to those who on Tipeee, Utip, or via the little join button allow us today to make a living from it and to embark on such long and crazy formats. So just love, hearts on you as big as the observable universe. And also to my buddy Maxu, to Sebastian, Cyril, Thibaut, and Valentin. The guy who hides behind his seat and edits each episode of this series, and who still managed to visualize black holes in the dark. A hard-working person I like who has more severe dyslexia than I do. He mainly operates on the SuperCali, Stupid Economics channel. Go take a little tour over there to dive into more earthly things. Always dissected, with talent and with honor. And I almost forgot one last thing. If you are one of the dodos who stayed until now in a pre-premiere, I wanted to tell you a couple of words about a project even stranger than this one. A somewhat crazy video project. In fact, a completely crazy and technically very ambitious project that we aim, redundancy, to shoot entirely in the water. And to embark on something like this, we need you. I'll keep it brief since we'll return shortly with project images to discuss. But there you have it. If you go to the link at the bottom of the proposal under the video, you will be the first to know what a good part of the year will look like. We hope so anyway. Numerous quick previews of this on Instagram. And with that, curtain.